To see today new topic which is called as what is turbine and types of turbine. So turbine is a rotary mechanical device that extracts energy from fast moving fluid or flow of water, steam, gas, air or other fluid and converts it into useful work. So there are different types of turbine. Basic type of turbines are water turbine, steam turbine, gas turbine and wind turbine. Although same principles apply to all turbines, the specific design sufficiently to differ sufficiently to merit separate descriptions. The working principle is simple. When fluid strikes the blade, the blades are displaced, which produces rotational energy. When turbine shaft is directly coupled to electric generator, mechanical energy is converted into electric energy. This electric energy is known as hydroelectric power. So here we can see that water is going to strike on the blades and blades are going to rotate and that is going to generate electricity. Different types of water turbines are impulse turbine and reaction turbine. Impulse turbine, they are nothing but the nozzle is going to hit water on the buckets and because of which bucket is going to rotate in anti-clockwise direction. So these are nothing but buckets. So an impulse turbine is a fast moving fluid which is fired through nozzle at a turbine blade to make them spin around. The impulse turbine fluid is forced to hit the turbine at high speed. Now we are going to see the different types of impulse turbine. Impulse turbine are two types, Pelton wheel turbine and cross flow turbine. What is Pelton wheel turbine? Pelton wheel turbine is used for high head, low flow power plants and it was invented in the year 1870 by Lester L. Pelton. Pelton will operate best with 50 to 2000 meter and flow rate is 4 to 15 meter cube per second. So here you can see the nozzle is hit the buckets and the bucket is going to rotate and is going to produce electricity. So this is the actual diagram of buckets. What is the application of Pelton wheel? As the definition says, Pelton wheels are preferred when available water resources have relatively high head at low flow rate. Then cross flow turbine. Cross flow turbine are developed by Anthony Mickle in the year 1902 and they are designed for low head between 10 to 70 meter. This is the diagram how the cross flow turbine are designed. What is the application of cross flow turbine? It is peak efficiency of cross flow turbine is somewhat less than Kaplan turbine and Francis turbine. It has low price and good regulation. So wherever low head is required, these cross flow turbines are preferred. Now we are going to see reaction turbine. Reaction turbine is nothing but a torque which is developed by the reacting fluid pressure. Okay, torque which is developed by reacting fluid pressure. The pressure fluid changes as it passes through the turbine rotor blade. So water is going to flow from this blade. So because of which torque is developed and these blades are going to rotate. Okay. So actual diagram you will see over here. So this is the way how the reaction turbine. In reaction turbine, this water is going to flow through a nozzle, and because of this rotary action, the turbine is going to rotate and produce electricity. But unlike in impulse turbine, water jet is going to hit on the buckets, and then the shaft is going to rotate. Reaction turbine and impulse turbine. This is the difference. um, like rotating nozzle is injected inside the shaft, but jet jet of water is going to hit on the buckets. So types of reaction turbine: there is Kaplan turbine, Francis turbine, kinetic turbine. So first we will see what is Kaplan turbine. Kaplan turbine is a water turbine which has adjustable blades and is used for low head and high discharges. It was developed in the year 1913 by Australian professor Victor Kaplan. Kaplan turbine is an inward reaction turbine, which means that the working fluid changes pressure as it moves towards the turbine and gives up its energy. So this is the way how the diagrams looks. This is the side view. This is the top view. Water is going to enter inside this spiral casing, and on the guide vanes it is going to hit, and because it is going to hit on the guide vanes, it is going to rotate, and because of which this electricity is produced. This is a side view. Inlet water is going to draft tip. So different parts of Kaplan turbine: hub, runner blade, hub cover. What are the application of Kaplan turbine? They are widely used throughout the world for electric power production. They cover the lowest head hydrosides and especially suited for high flow conditions. Normally, high discharges Kaplan turbines are used. Francis turbine. Francis turbines was developed by James Francis, used for medium head and medium discharges. So after Kaplan, medium head and medium discharges, it is ranging from 10 to 700 meter cube per second, and medium head 45 to 400 meter. So this is the way how the water is going to enter inside the vanes, guide vanes, and the shaft is going to rotate. This is the actual diagram. What is the application of Kaplan Francis turbine? Francis type cover a head range from 40 to 600 meter, and the efficiency decreases as flow decreases. These are used for pump storage, where reservoir is filled with turbine driven by generator acting as large electric motor during periods of low power demand. So pump storage system Francis turbine is going to be used. Lastly, kinetic turbines are called free flow turbines, generate electricity from kinetic energy present in the flowing water. So water can be river, man-made channels, tidal water, or ocean currents. So their diagram will depict what is the meaning of kinetic turbine. So these types of turbines are kept inside the water or flowing river, and because of which these rotating blades electricity is going to generate. So here we can see overall in Maharashtra what happens about the capacity. So Koyna is the largest dam in this Maharashtra, having the capacity of 1960 megawatts. Srisalem dam in the southern part is having 1670 megawatts of energy, and it is having Francis turbine. So in this way we can see normally for high head Pelton wheel turbine is used, and for medium head Francis turbines are used. Thank you very much.